Ever since we learned to stack stones, humanity has chased the sky. It is a primal, almost spiritual impulse. From the first pyramids reaching for the sun, to the soaring cathedrals of the Middle Ages, we have always looked up and dreamed of going higher. This is a story etched into our very DNA, a testament to our relentless ambition. We build not just for shelter, but for legacy. We build to conquer, to inspire, and to see just how far we can push the boundaries of what is possible. It's a competition not just against each other, but against gravity itself. This obsession has given rise to the modern marvels we call skyscrapers, titans of steel and glass that redefine city skylines and challenge our perception of scale. But what happens when we push even further? What happens when our ambition outpaces our technology, our funding, or even our political will? Today, we journey into the world of megastructures, the giants that promise to dwarf everything that has come before. These are the projects teetering on the edge of reality, caught between groundbreaking vision and catastrophic failure. We will explore 10 colossal endeavors, some rising from the desert sands, others frozen in time, and some that exist only in the realm of theory. Each tells a story of human ingenuity, economic might, and the often harsh realities of turning dreams into concrete and steel. We ask ourselves the fundamental question that has driven us for millennia. How high can we go? We begin our journey in Saudi Arabia with a structure that has become a legend in its own time. At number 10, the Jeddah Tower. For years, it stood as a silent concrete monument to a dream deferred. Its construction halted, a stark skeleton against the desert sky. But as of early 2025, the cranes are stirring once more. The silence has been broken by the sounds of renewed purpose. The ambition here is not merely to build tall, to create a new benchmark for human achievement, a vertical city, the centerpiece of a new economic powerhouse. The plan is staggering. To pierce the 1,000-meter mark, a full kilometer into the sky. If completed, it would stand roughly 180 meters taller than the current record holder, the Burj Khalifa. Imagine that. The difference in height alone would be the equivalent of a 60-story skyscraper. This restart is not just a matter of pouring more concrete. It is a race against time, a battle against immense engineering challenges. Engineers must account for wind forces at such an altitude that are unlike anything encountered before. The logistics of moving materials and people a full kilometer vertically are a puzzle in themselves. And beneath it all lies the quiet pressure of a national vision, a desire to create a landmark that will be spoken of for generations. The Jeddah Tower is more than a building. It is a statement of intent, a spear aimed directly at the heavens. Our next stop takes us to Tianjin, China, and a tower that symbolizes both immense ambition and the perils of economic headwinds. Coming in at number 9 is the Golden Finance 117. For a long time, this colossal structure was the world's tallest ghost scraper, an empty shell topped out but unfinished, a victim of a market downturn. Its stark, unadorned frame became an emblem of stalled progress, a cautionary tale whispered among developers worldwide. But like its counterpart in Jeddah, there is a new chapter being written. Construction has reportedly resumed on this 128-story giant. The goal is to finally complete the vision, to fill its empty floors and bring life to its silent corridors. What makes this tower particularly fascinating from an engineering standpoint is its design. Unlike the spires that crown most of the world's tallest buildings, Golden Finance 117 is a flat-topped super tall. This presents a unique set of structural challenges, especially concerning wind load and the distribution of weight at its apex. It is a brute force approach to height, a massive column of strength. Finishing a project of this scale after such a long pause is a monumental undertaking. Systems installed years ago may now be obsolete. The exterior cladding must be meticulously checked and completed to withstand the elements, and the internal fit-out is a project of city-like proportions. The revival of Golden Finance 117 is a test of resilience, a promise that even the most daunting setbacks can be overcome, and a chance to see a truly unique giant finally take its place on the skyline. We return to the city that has become synonymous with architectural superlatives, Dubai. Dubai. Here, at number 8, a new challenger is rising to reclaim the vertical throne. Meet the Burj Azizi. In a city that already boasts the world's tallest building, the ambition to build even higher is a constant driving force. This new tower is not just another skyscraper. It's a declaration that Dubai's era of mega builds is far from over. It is a direct response, a new jewel intended for the city's crown. Projected to stand at approximately 725 meters, luxury residences, commercial space, high-end hospitality. It aims to be a city within a city, a self-contained ecosystem of life and commerce stacked vertically. To achieve this, its designers must push the boundaries of modern construction. This isn't just about height. It's about creating a habitable, sustainable, and safe environment at an altitude where the air itself is thinner and the winds are a relentless foe. The project demands cutting-edge materials, likely composites and alloys not yet in common use, to manage weight without sacrificing strength. Advanced wind mitigation systems, such as tuned mass dampers and aerodynamic shaping, will be critical to ensure the comfort and safety of its occupants. And of course, a project of this magnitude requires a massive, almost unimaginable investment. The Burj Azizi is a testament to Dubai's unwavering belief in the power of iconic architecture to shape its identity and its future. Chapter 4. From the deserts of the Middle East, we travel to the heartland of America, Oklahoma City, an unlikely setting for one of the world's most ambitious skyscraper proposals. At number 7, Legends Tower. A project as much about symbolism as it is about engineering. Proposed to reach a staggering 581 meters, or 1,907 feet, a nod to Oklahoma's founding year. It would shatter records. The vision: a true vertical city, a mixed-use development to revitalize downtown and create a new icon for the American spirit. Hotels, residential units, commercial spaces, all soaring to dwarf today's American champion, One World Trade Center. A bold statement that megastructures need not be coastal, but huge dreams face huge obstacles. The biggest, regulatory hurdles. A tower this tall demands FAA review and approval and would profoundly impact regional airspace. Financing is another mountain, colossal capital often at the mercy of volatile markets. The future of Legends Tower is clouded by delays, a reminder that even the most powerful dreams can be grounded by bureaucracy and budgets. Chapter 5. Now for a project that redefines the very concept of building a structure so audacious it borders on science fiction. At number 6, we have The Line, the centerpiece of Saudi Arabia's NEOM project. The original vision was nothing short of revolutionary. A linear city just 200 meters wide but stretching for tens of kilometers across the desert, encased in a mirrored facade and rising 500 meters into the air. It was not a tower, but a wall, a continuous structure intended to house millions of people in a car-free, carbon-neutral environment. The sheer scale is difficult to comprehend. It was conceived as an architectural singularity, a complete break from the history of urban development. Its construction would require a mobilization of resources and labor unseen in human history. The logistics of building a 500-meter-tall structure that runs for dozens of kilometers, if not hundreds, presents engineering challenges that are completely unprecedented. How do you lay a foundation across such varied terrain? How do you manage the thermal expansion of such a long, continuous object under the desert sun? But the grand vision has collided with a harsh reality. The project, in its original breathtaking scope, is now reportedly scaled back or suspended in parts. The dream of a 170-kilometer-long city has been reduced, for now, to a much smaller, more manageable segment. The line has become a powerful lesson in the limits of mega-projects. It exposes how even the most well-funded and politically backed visions can be constrained by the practicalities of engineering, the realities of economics, and the fundamental question of whether such a place is even desirable to live in. Chapter 6. Our journey takes us back to China, a nation that has dominated skyscraper construction for the past 2 decades. In the city of Dongguan, at number 5, a new super-tall is taking shape. This 450-meter project, though currently unnamed in many international reports, is emblematic of the innovation of the early 2020s. It represents the next evolution in high-rise design, building on lessons from the first great wave of Chinese super-talls. It is quieter, perhaps, but no less significant. This tower is a showcase for modern structural systems. Engineers are deploying advanced computational frameworks to achieve stability and strength with greater efficiency and using less material than ever before. The core of the building, the massive spine that contains elevators and utilities, is a marvel of planning. The logistics of the elevator systems alone are a profound challenge. How to move thousands of people efficiently up and down a nearly half-kilometer tower without crippling bottlenecks or eating into valuable floor space. Beyond engineering, a tower this size reshapes the urban fabric. It becomes a new center of gravity for the city, altering traffic patterns, straining public transport, casting literal shadows over its neighbors. The Dongguan project is a case study in modern urban integration, a test of whether a city can absorb a massive vertical injection of population. Egypt. At number 4 is the iconic tower, the centerpiece of the nation's new administrative capital, rising from the desert outside Cairo. Standing at nearly 394 meters, it is already the tallest building in Africa, a powerful landmark signifying a new era of development for the region. It is a bold statement, a modern obelisk that announces Egypt's entry into the super-tall era on the world stage. The construction of the iconic tower is a story of global collaboration, but also of developing regional expertise. It represents a massive transfer of knowledge as local engineers and workers master the complex techniques required for super-tall construction. However, building in this region comes with its own specific set of challenges. The design must account for the seismic activity of the area, incorporating sophisticated systems to withstand earthquakes. The intense desert climate also requires innovative solutions for cooling and facade maintenance. More than just a building, the iconic tower is the anchor of an entirely new city. Its success or failure will be tied to the success of this grand urban experiment. Can it attract the businesses and residents needed to thrive? Can it integrate with the new capital's infrastructure and avoid becoming an isolated monument? The tower is a beacon of hope and a symbol of national pride, but it also carries the immense weight of a nation's aspirations on its steel shoulders, you know. For number 3, we leave the ground entirely, and we venture into theoretical physics and materials science. This is the space elevator, the ultimate megastructure, a concept that has captivated scientists and dreamers for over a century. Simple in principle, mind-bogglingly complex in practice. A physical tether, a ribbon from Earth reaching geostationary orbit, over 35,000 kilometers long. If built, it would revolutionize our relationship with space. It would end our reliance on explosive rockets. Access to orbit would become routine, an elevator ride. The cost to put satellites into orbit would plummet. Scientific instruments would be far cheaper to deploy. People could travel to space more affordably. The solar system would open for exploration and exploitation. The single greatest engineering feat, a bridge to the stars. But the obstacles are colossal. The primary challenge: materials. Carbon nanotubes, graphene. We can't yet make them at the needed scale and quality. Then the dynamics: Earth's rotation, atmospheric drag, vibrations, impacts from space debris. For now, the space elevator is a powerful theory, a distant dream on the horizon. At number 2, we look not at a single project, but at a widespread phenomenon that tells a sobering story about the limits of growth. This is the crisis of scale, the hundreds of stalled high-rise projects scattered across China. For years, the nation built taller and faster than any other in history. Cities competed to have the most impressive skylines, and towers of 200 meters or more rose at a dizzying pace. It was a golden age of construction, fueled by a booming economy and boundless optimism. But that momentum has hit a wall. A confluence of financial shocks, shifting government regulations, a cooling property market has brought hundreds of these ambitious projects to a grinding halt. What were once symbols of prosperity have become concrete skeletons, monuments to overreach. These stalled towers represent billions of dollars in frozen investment and shattered dreams for the cities they were meant to transform. They are a stark, physical reminder of how fragile a construction boom can be. This great stall reveals the intricate web of dependencies that underpins every mega construction. It is not enough to have the engineering know-how. You must also have a stable financial system, consistent regulatory support, and a market that can absorb the new space being created. When any one of these pillars weakens, the entire edifice can come to a standstill. This crisis is a crucial lesson, a moment of reckoning for the global construction industry about the true costs and risks of chasing the sky. And finally, at number 1, we return to the grandest vision of all. A concept that encompasses many of the themes we have explored. We look at the fate of NEOM and other scaled-back mega-developments around the world. These were projects drawn in epic CGI, promising to reshape entire regions. They were sold not just as buildings or cities, but as new paradigms for human existence, powered by technology and limitless ambition. They were to be our future, rendered in breathtaking detail. These visions spanned deserts and coastlines, and linear metropolises stretching to the horizon. They captured the global imagination, representing the absolute apex of humanity's appetite for building bigger, for creating new worlds from scratch. The budgets were counted in the trillions, the timelines in decades, and the promises seemed to defy the very laws of physics and economics. It was a beautiful, compelling dream of what we could be. But now, these projects are facing the harsh light of day. The grand vision of NEOM, as we have seen, is being reevaluated. Other mega-developments are facing similar contractions, forced to scale back their epic scope in the face of budgetary reality and logistical nightmares. This grand contraction serves as our final and most profound lesson. It is a test of our collective appetite for the monumental. It forces us to ask, is bigger always better? And at what point does the dream of a perfect engineered future become a fantasy we simply cannot afford? From the restarting giants of Jeddah and Tianjin to the theoretical ribbon of a space elevator, we have witnessed the breathtaking scope of human ambition. We have seen dreams cast in steel and glass, some reaching for the clouds, others frozen in time. Each of these 10 stories reveals a fundamental truth about our civilization. Our deep, unyielding drive to build, to overcome, and to leave a mark that will outlast us. It is a story of incredible genius, of immense wealth, and of the humbling power of reality. These projects are more than just structures. They are battlegrounds where vision clashes with physics, where finance meets politics, and where the dreams of a few are weighed against the needs of many. Some will undoubtedly be completed, becoming the new icons of our age and inspiring the next generation of builders to aim even higher. Others may remain as they are, cautionary tales, modern ruins that speak to the limits of our reach. They remind us that for every triumph that scrapes the sky, there are countless visions that never leave the drawing board. The future of the skyline is being written right now, in boardrooms, on construction sites, and in materials science labs across the globe. The race upward continues, a relentless, centuries-old pursuit that shows no signs of stopping. But the question remains as we stand here, at the precipice of a new era of building,